Giles Montessori and School. Grade 9, Physics for Federal Board Islamabad, 2025 onwards syllabus. Chapter 2, Foundation of Measurement in Physics from Cantab Publisher book. This also covers portion of Chapter 1, Physical Quantities and Measurement, of NBF book syllabus 2025 onwards. Dear students, this program will help you to prepare for your Federal Board exam, particularly for preparation of MCQs, definitions and short answers. We hope this is beneficial. Let's start. Q1. What branch of physics deals with the study of motion and its causes? A. Thermodynamics. B. Mechanics. C. Optics. D. Electromagnetism. The correct option is B. The branch of physics that deals with the study of motion and its causes is mechanics. Q2. Which of the following is a derived quantity? A. Mass. B. Length. C. Velocity. D. Time. The correct option is C. Velocity is a derived quantity, as it is calculated from base quantities like length and time. Q3. What is the SI unit of force? A. Joule. B. Newton. C. Watt. D. Pascal. The correct option is B. The SI unit of force is Newton. Q4. If an object has a mass of 5 kilograms and the acceleration due to gravity is 9.8 meters per square second, what is the weight of the object? A. 19.6 n. B. 24.5 n. C. 39.2 n. D. 49.0 n. The correct option is D. The weight of the object is calculated as W equals mg equals 5 times 9.8 equals 49.0. Q5. What is the gravitational field strength on Earth? A. 9.8 n per kilogram. B. 10.2 n kilogram. C. 8.9 n per kilogram. D. 12.0 n kilogram. The correct option is A. The gravitational field strength on Earth is 9.8 n kilogram. Q6. Which of the following is the correct SI unit for measuring time? A. Minute. B. Hour. C. Second. D. Day. The correct option is C. The correct SI unit for measuring time is the second. Q7. The acceleration due to gravity on the moon is approximately 1.6 meters per square second. If an object weighs 60 n on Earth, what would it weigh on the moon? A. 6 n. B. 10 n. C. 9.8 n. D. 60 n. The correct option is C. Q8. What is the formula for calculating weight? A. W equals mg. B. W equals ma. C. W equals mv. D. W equals mv squared. The correct option is A. The formula for calculating weight is W equals mg. Q9. Which of the following is a base quantity? A. Area. B. Volume. C. Length. D. Velocity. The correct option is C. Length is a base quantity. Q10. What is the SI unit of electric current? A. Volt. B. Ampere. C. Coulomb. D. Ohm. The correct option is B. The SI unit of electric current is ampere. Q11. Which of the following is an example of a derived quantity? A. Mass. B. Length. C. Velocity. D. Time. The correct option is C. Velocity is a derived quantity. Q12. What is the SI unit of thermodynamic temperature? A. Celsius. B. Fahrenheit. C. Kelvin. D. Joule. The correct option is C. The SI unit of thermodynamic temperature is Kelvin. Q13. Which of the following quantities is non-physical? A. Speed. B. Force. C. Happiness. D. Temperature. The correct option is C. Happiness is a non-physical quantity. Q14. What is the correct SI unit for luminous intensity? A. Candela. B. Lumen. C. Lux. D. Watt. The correct option is A. The correct SI unit for luminous intensity is candela. Q15. Which of the following is the correct symbol for the unit ampere? A. Am. B. A. C. Amp. D. MA. The correct option is B. The correct symbol for the unit ampere is A. Q16. What is the SI unit of light intensity? A. Watt. B. Candela. C. Lumen. D. Lux. The correct option is B. The SI unit of light intensity is candela. Q17. The SI unit of temperature is A. Celsius. B. Fahrenheit. C. Kelvin. D. Rankine. The correct option is C. The SI unit of temperature is Kelvin. Q18. What is the SI unit for measuring the amount of a substance? A. Kilogram. B. Mole. C. Ampere. D. Liter. The correct option is B. The SI unit for measuring the amount of a substance is mole. Q19. Which of the following is a derived unit of physical quantity? A. Meter. B. Kilogram. C. Newton. D. Mole. The correct option is C. Newton is a derived unit of physical quantity. Q20. In the International System of Units, SI, the unit of force is A. Joule. B. Newton. C. Watt. D. Pascal. The correct option is B. In the SI system, the unit of force is Newton. Q21. Which of the following quantities is measured in Hertz, Hz, in the SI system? A. Force. B. Frequency. C. Pressure. D. Power. The correct option is B. Frequency is measured in Hertz, Hz, in the SI system. Q22. What is the SI unit of pressure? A. Newton. B. Joule. C. Pascal. D. Watt. The correct option is C. The SI unit of pressure is Pascal. Q23. The SI unit of power is A. Joule. B. Watt. C. Newton. D. Pascal. The correct option is B. The SI unit of power is watt. Q24. The derived unit for density in the SI system is A. Kilogram per cubic meter, kilogram per cubic meter. B. Meter per second squared, meter per square second. C. Kilogram meter per second, kilogram meter per second. D. Kilogram per meter, kilogram per meter. The correct option is A. The derived unit for density in the SI system is kilogram per cubic meter, kilogram per cubic meter. Q25. The SI unit for measuring electric charge is A. Coulomb. B. Ampere. C. Joule. D. Volt. The correct option is A. The SI unit for measuring electric charge is Coulomb. Q26. Which of the following numbers is written in scientific notation? A. 300. B. 2.3 times 10 to the power of 3, C. 5.7, D. 0.45 times 10 to the power of 1. The correct option is B. The number 2.3 times 10 to the power of 3 is written in scientific notation. Q27. What is the power of 10 for the number 0.003? A. 10 to the power of 2. B. 10 to the power of 0. C. 10 squared. D. 10 cubed. The correct option is D. The power of 10 for the number 0.003 is 10 cubed. Q28. In scientific notation, a number is expressed as A times 10 to the power of n, B. A times 10 to the power of 0, C. A plus 10 to the power of n, D. A minus 10 to the power of n. The correct option is A. In scientific notation, a number is expressed as a times 10 to the power of n. Q29. When converting 5 million meters to kilometers, what is the result? A. 5 kilometers. B. 500 kilometers. C. 5,000 kilometers. D. 5 million kilometers. The correct option is C. When converting 5 million meters to kilometers, the result is 5,000 kilometers. Q30. Which of the following is a correct example of a number in scientific notation? A. 0.003. B. 2.3 times 10 squared. C. 4.56 times 10 to the power of 1. D. 100. The correct option is B. 2.3 times 10 squared and C. 4.56 times 10 to the power of 1. Q30. A. What is a physical quantity? A. A quantity that can only be described. B. A quantity that can be measured and expressed with units. C. A feeling or emotion. D. A type of food. Correct answer is B. A physical quantity is any quantity that can be measured and expressed numerically with units, such as length, meters, time, seconds, or mass, kilograms. Q30. B. What are base quantities in physics? A. Quantities that are derived from other physical quantities. B. Quantities that can only be estimated but not measured. C. Fundamental quantities that are measured directly and define other quantities. D. Q30. B. What are base quantities in physics? A. Quantities that are derived from other physical quantities. B. Quantities that can only be estimated but not measured. C. Fundamental quantities that are measured directly and define other quantities. D. Correct answer is C. Fundamental quantities that are measured directly and define other quantities. Q30. C. What are derived quantities in physics? A. Quantities that are measured directly without any calculations. B. Quantities that are formed by combining base quantities through calculations. C. Quantities that have no relation to base quantities. D. Q30. C. What are derived quantities in physics? A. Quantities that are measured directly without any calculations. B. Quantities that are formed by combining base quantities through calculations. C. Quantities that have no relation to base quantities. D. Correct answer is B. Quantities that are formed by combining base quantities through calculations. Q30. D. Which of the following sets includes only base quantities? A. Time, mass, temperature. B. Speed, force, energy. C. Velocity, acceleration, power. D. Work, momentum, torque. Correct answer is A. Time, mass and temperature. Base quantities are fundamental physical quantities that are not derived from other quantities. In SI units, the base quantities include time, mass, length, electric current, temperature, amount of substance, and luminous intensity. Q30. A. If the density is a derived quantity, what could be the base quantities used to express it? A. Mass and length. B. Time and length. C. Force and speed. D. Energy and work. Correct answer is A. Mass and length. Density is defined as mass per unit volume. Density equals mass, volume. Since volume is derived from length, length cubed, the base quantities used to express density are mass and length. Q30. F. Which of the following is not a derived unit in the SI system? A. Newton. B. Pascal. C. Ampere. D. Joule. Correct answer is C. Ampere is a base unit in the SI system, while Newton, Pascal, and Joule are derived units. Q30 grams. A scientist is measuring the amount of substance in a chemical reaction. Which SI base unit will be appropriate for this measurement? A. Kelvin. B. Mole. C. Candela. D. Ampere. Correct optio is B. Mole. The mole is the SI base unit for measuring the amount of substance. Q31. If you have 300 milligrams, how many grams do you have? A. 0.03 grams. B. 3 grams. C. 0.3 grams. D. 300 grams. The correct option is C. 300 milligrams is equal to 0.3 grams. Q32. What prefix represents 10 to the power of 6? A. Kilo. B. Mega. C. Giga. D. Tera. The correct option is B. The prefix mega represents 10 to the power of 6. Q33. What is the correct scientific notation for the number 0.00045? A. 4.5 times 10 to the power of 4. B. 4.5 times 10 cubed. C. 0.45 times 10 squared. D. 4.5 times 10 to the power of 2. The correct option is A. The correct scientific notation for the number 0.00045 is 4.5 times 10 to the power of 4. Q34. What does the prefix nano represent in terms of power of 10? A. 10 to the power of 9. B. 10 to the power of 6. C. 10 cubed. The correct option is A. The prefix nano represents 10 to the power of 9. Q35. How is the number 1,400,000 written in scientific notation? A. 1.4 times 10 to the power of 6. B. 1.4 times 10 to the power of 5. C. 1.4 times 10 to the power of 7. D. 1.4 times 10 to the power of 4. The correct option is A. The number 1,400,000 is written in scientific notation as 1.4 times 10 to the power of 6. Q36. What is the correct unit for measuring volume in the SI system? A. Kilogram. B. Meter. C. Liter. D. Ampere. The correct option is C. The correct unit for measuring volume in the SI system is liter. Q37. When writing 450 in scientific notation, which of the following is correct? A. 4.5 times 10 to the power of 1. B. 45 times 10 to the power of 1. C. 4.5 times 10 to the power of 2. D. 0.45 times 10 to the power of 2. The correct option is C. The number 450 in scientific notation is written as 4.5 times 10 to the power of 2. Q38. If a unit symbol is named after a person, how should it be written? A. Always in lowercase. B. The first letter capitalized. C. All letters capitalized. D. None of the above. The correct option is B. If a unit symbol is named after a person, the first letter should be capitalized. Q39. Which unit symbol is written correctly with a prefix? A. km for kilometers. B. km for kilometers. C. km for kilometers. D. km for kilometers. The correct option is C. The correct unit symbol with a prefix is km for kilometers. Q40. What is the order of magnitude of 7000? A. 10 to the power of 3. B. 10 to the power of 4. C. 10 to the power of 2. D. 10 to the power of 5. The correct option is B. The order of magnitude of 7000 is 10 to the power of 4. Q41. Which of the following represents the correct use of a space in SI units? A. 25 kilograms. B. 25 kilogram. The correct option is B. The correct use of a space in SI units is 25 kilogram. Q42. What is the value of 6 times 10 to the power of 2 divided by 3 times 10 to the power of 4? A. 2 times 10 to the power of 6. B. 2 times 10 to the power of 2. C. 2 times 10 squared. D. 2 times 10. The correct option is C. The value of 6 times 10 to the power of 2 divided by 3 times 10 to the power of 4 is 2 times 10 squared. Q43. What is the result of multiplying 2 times 10 to the power of 3 by 3 times 10 to the power of 6? A. 6 times 10 to the power of 9. B. 6 times 10 to the power of 8. C. 5 times 10 to the power of 9. D. 5 times 10 to the power of 8. The correct option is A. The result of multiplying 2 times 10 to the power of 3 by 3 times 10 to the power of 6 is 6 times 10 to the power of 9. Q44. When adding 4.56 times 10 to the power of 7 and 3.4 times 10 to the power of 4, the exponent should be adjusted to A. 10 to the power of 7. B. 10 to the power of 4. C. 10 to the power of 1. D. 10 to the power of 8. The correct option is A. When adding 4.56 times 10 to the power of 7 and 3.4 times 10 to the power of 4, the exponent should be adjusted to 10 to the power of 7. Q45. How is 1500 microseconds written in scientific notation? A. 1.5 times 10 cubed s. B. 1.5 times 10 squared s. C. 1.5 times 10 to the power of 3s. D. 1.5 times 10 to the power of 6s. The correct option is C. 1500 microseconds is written in scientific notation as 1.5 times 10 to the power of 3s. Q46. What is the purpose of understanding the least count of a measurement instrument? A. To measure the smallest possible length. B. To estimate the precision of measurements. C. To determine the accuracy of the measurement. D. To avoid systematic errors. The correct option is B. The purpose of understanding the least count of a measurement instrument is to estimate the precision of measurements. Q47. Which of the following best describes a systematic error? A. Errors due to instrument sensitivity. B. Errors that occur unpredictably. C. Consistent and predictable errors. D. Errors caused by environmental changes. The correct option is C. A systematic error is consistent and predictable. Q48. A bent ruler leading to incorrect measurements is an example of A. Random error. B. Systematic error. C. Zero error. D. Human error. The correct option is B. A bent ruler leading to incorrect measurements is an example of systematic error. Q49. What is a key method to reduce systematic errors? A. Taking multiple measurements. B. Using a stopwatch. C. Calibrating the instrument. D. Increasing the number of trials. The correct option is C. A key method to reduce systematic errors is calibrating the instrument. Q50. What is random error? A. Errors caused by faulty instruments. B. Errors that occur in a predictable pattern. C. Unpredictable fluctuations in measurements. D. Errors that can be completely eliminated. The correct option is C. Random error refers to unpredictable fluctuations in measurements. Q51. How can random errors be minimized? A. By eliminating zero error. B. By using more precise instruments. C. By measuring only once. D. By ignoring environmental factors. The correct option is B. Random errors can be minimized by using more precise instruments. Q52. Averaging multiple measurements is primarily used to A. Increase the measurement precision. B. Eliminate systematic errors. C. Reduce random errors. D. Measure the least count. The correct option is C. Averaging multiple measurements is primarily used to reduce random errors. Q53. In the context of measuring time intervals, what is a recommended method to increase accuracy? A. Using a less sensitive stopwatch. B. Measuring shorter time intervals. C. Counting the time for multiple swings. D. Increasing the reaction time. The correct option is C. Counting the time for multiple swings is a recommended method to increase accuracy. Q54. To calculate the average thickness of an object, what should you do with the measurements? A. Multiply the measurements. B. Divide the measurements. C. Add the measurements and divide by the number of measurements. D. Subtract the measurements. The correct option is C. To calculate the average thickness, add the measurements and divide by the number of measurements. Q55. When measuring the time period of a simple pendulum, which of the following steps is recommended to obtain an accurate result? A. Measuring the time for a single swing. B. Repeating the measurement only once. C. Measuring the time for multiple swings and averaging the result. D. Using a stopwatch with a slow reaction time. The correct option is C. Measuring the time for multiple swings and averaging the result is recommended for accuracy. Q56. What is the least count of a measuring instrument? A. The smallest measurement that can be taken accurately with the instrument. B. The largest measurement that can be taken accurately with the instrument. C. The average measurement that can be taken with the instrument. D. The most common measurement taken with the instrument. The correct option is A. The least count of a measuring instrument is the smallest measurement that can be taken accurately with the instrument. Q57. If a ruler has markings at each millimeter, what is its least count? A. 1 cm. B. 1 mm. C. 0.1 cm. D. 0.01 mm. The correct option is B. If a ruler has markings at each millimeter, its least count is 1 mm. Q58. What does a smaller least count indicate about an instrument? A. Lower precision. B. Higher precision. C. Lower accuracy. D. Higher accuracy. The correct option is B. A smaller least count indicates higher precision. Q59. Which instrument typically has a least count of 0.01 mm? A. Vernier caliper. B. Micrometer screw gauge. C. Meter ruler. D. Stopwatch. The correct option is B. A micrometer screw gauge typically has a least count of 0.01 mm. Q60. What does precision in a measuring instrument refer to? A. The ability to give measurements close to the true value. B. The ability to provide highly exact and detailed measurements. C. The average value of multiple measurements. D. The largest measurement that can be taken accurately with the instrument. The correct option is B. Precision in a measuring instrument refers to the ability to provide highly exact and detailed measurements. Q61. Which of the following is an example of a measurement that is precise but not accurate? A. Measurements that are close to the true value but not close to each other. B. Measurements that are close to each other but not to the true value. C. Measurements that are neither close to the true value nor to each other. D. Measurements that are both close to each other and to the true value. The correct option is B. Measurements that are close to each other but not to the true value are precise but not accurate. Q62. What affects the accuracy of measurements? A. Precision. B. Least count. C. Random and systematic errors. D. Calibration of the instrument. The correct option is C. Random and systematic errors affect the accuracy of measurements. Q63. Which type of error can be reduced by improving the least count of an instrument? A. Random errors. B. Systematic errors. C. Both random and systematic errors. D. Neither random nor systematic errors. The correct option is A. Random errors can be reduced by improving the least count of an instrument. Q64. What is the primary benefit of having a smaller least count in a measuring instrument? A. Greater speed in taking measurements. B. Greater reliability in repeated measurements. C. Ability to measure larger objects. D. Ability to discriminate smaller differences in measurements. The correct option is D. The primary benefit of a smaller least count is the ability to discriminate smaller differences in measurements. Q65. What does accuracy in a measurement indicate? A. How close the measurements are to the true value. B. How close the measurements are to each other. C. The smallest difference in measurements that can be detected. D. The ability to repeat measurements with the same result. The correct option is A. Accuracy in a measurement indicates how close the measurements are to the true value. Q66. What is the primary use of a measuring tape in scientific measurements? A. Measuring the mass of an object. B. Measuring long distances without perfect accuracy. C. Measuring very small objects. D. Measuring time intervals. The correct option is B. The primary use of a measuring tape is to measure long distances without perfect accuracy. Q67. What is the least count of a typical meter rule? A. 1 cm. B. 10 mm. C. 1 mm. D. 0.1 mm. The correct option is C. The least count of a typical meter rule is 1 mm. Q68. Which type of error can be avoided by aligning your eye directly over the measurement point on a meter rule? A. Systematic error. B. Random error. C. Zero error. D. Parallax error. The correct option is D. Parallax error can be avoided by aligning your eye directly over the measurement point. Q69. What is the least count of vernier calipers? A. 1 mm. B. 0.1 mm. C. 0.01 centimeters, D. 10 millimeters. The correct option is C. The least count of vernier calipers is 0.01 centimeters. Q70. How is the least count of vernier calipers calculated? A. By multiplying the smallest division on the main scale by the number of divisions on the vernier scale. B. By dividing the smallest division on the main scale by the number of divisions on the vernier scale. C. By subtracting the smallest division on the vernier scale from the main scale. D. By adding the smallest division on the vernier scale to the main scale. The correct option is B. The least count of vernier calipers is calculated by dividing the smallest division on the main scale by the number of divisions on the vernier scale. Q71. What type of error is caused if the 0 mark on the vernier scale does not align with the 0 mark on the main scale when the jaws of the caliper are fully closed? A. Parallax error. B. Systematic error. C. Random error. D. Zero error. The correct option is D. If the 0 mark on the vernier scale does not align with the 0 mark on the main scale, it causes a zero error. Q72. How can zero error in vernier calipers be corrected? A. By adding the zero error to the measured value. B. By subtracting the zero error from the measured value. C. By ignoring the zero error. D. By adjusting the vernier scale until there is no zero error. The correct option is B. Zero error in vernier calipers can be corrected by subtracting the zero error from the measured value. Q73. Which measuring instrument is more accurate than a meter rule for measuring lengths? A. Measuring tape. B. Vernier calipers. C. Stopwatch. D. Weighing scale. The correct option is B. Vernier calipers are more accurate than a meter rule for measuring lengths. Q74. How does a smaller least count affect the precision of an instrument? A. It decreases the precision. B. It increases the precision. C. It does not affect the precision. D. It decreases the accuracy. The correct option is B. A smaller least count increases the precision of an instrument. Q75. What is a common cause of random errors in using vernier calipers? A. Zero error. B. Misalignment of the vernier scale with the main scale. C. Parallax error. D. Use of a damaged instrument. The correct option is B. A common cause of random errors in using vernier calipers is misalignment of the vernier scale with the main scale. Q76. What strategy can be used to minimize random errors when using vernier calipers? A. Taking multiple readings and averaging them. B. Always starting measurements from the 0 mark. C. Only taking one measurement. D. Measuring in dim light conditions. The correct option is A. Taking multiple readings and averaging them can minimize random errors. Q77. Which instrument offers the highest precision for measuring lengths among those discussed? A. Measuring tape. B. Meter rule. C. Vernier calipers. D. Micrometer screw gauge. The correct option is D. The micrometer screw gauge offers the highest precision for measuring lengths. Q78. What is the least count of an instrument? A. The smallest difference in a reading that the instrument can measure. B. The largest difference in a reading that the instrument can measure. C. The average difference in a reading that the instrument can measure. D. The total difference in a reading that the instrument can measure. The correct option is A. The least count of an instrument is the smallest difference in a reading that the instrument can measure. Q79. If a ruler has markings at each millimeter, what is its least count? A. 0.1 mm, B 1 mm, C 10 mm, D 100 mm. The correct option is B. If a ruler has markings at each millimeter, its least count is 1 millimeter. Q80. Which of the following instruments is likely to have the highest precision? A. Vernier calipers with a least count of 0.1 mm, B. Meter ruler with a least count of 1 mm, C. Micrometer screw gauge with a least count of 0.01 mm, D. Measuring tape with a least count of 1 cm. The correct option is C. The micrometer screw gauge with a least count of 0.01 mm is likely to have the highest precision. Q81. The least count of a typical digital stopwatch is A. 0.1 seconds, B. 0.01 seconds, C. 1 second, D. 0.001 seconds. The correct option is B. The least count of a typical digital stopwatch is 0.01 seconds. Q82. Which of the following is true about the precision of a measuring instrument? A. It is related to the smallest measurement the instrument can take. B. It is related to the largest measurement the instrument can take. C. It is related to the average measurement the instrument can take. D. It is unrelated to the measurement capabilities of the instrument. The correct option is A. The precision of a measuring instrument is related to the smallest measurement it can take. Q83. The least count of an analog stopwatch is typically A. 0.1 seconds, B. 0.2 seconds, C. 0.01 seconds, D. 1 second. The correct option is A. The least count of an analog stopwatch is typically 0.1 seconds. Q84. If a meter ruler has a least count of 1 mm, how should you record a measurement of 5.5 cm? A. 5.50 cm, B. 5.500 cm, C. 5.5 cm, D. 5 cm. The correct option is A. If a meter ruler has a least count of 1 mm, a measurement of 5.5 cm should be recorded as 5.50 cm. Q85. Which of the following describes the concept of significant figures? A. The digits that are known with certainty plus the first uncertain digit. B. All the digits in a measurement. C. Only the non-zero digits in a measurement. D. Only the digits before the decimal point. The correct option is A. Significant figures are the digits that are known with certainty plus the first uncertain digit. Q86. What is the main reason for rounding off in calculations involving measurements? A. To simplify the calculation. B. To align with the precision of the measuring instrument. C. To reduce errors in the calculation. D. To increase the number of significant figures. The correct option is B. The main reason for rounding off in calculations involving measurements is to align with the precision of the measuring instrument. Q87. If a measurement is recorded as 0.00540 meters, how many significant figures does it have? A. 2, B. 3, C. 4, D. 5. The correct option is B. The measurement 0.00540 meters has 3 significant figures. Q88. When adding 105.214 and 203.4, to how many decimal places should the result be rounded? A. 1, B. 2, C. 3, D. 4. The correct option is A. When adding 105.214 and 203.4, the result should be rounded to 1 decimal place. Q89. Which hazard is associated with exposure to ultraviolet radiation in a laboratory? A. physical hazard, B. chemical hazard, C. biological hazard, D. safety hazard. The correct option is A. Exposure to ultraviolet radiation in a laboratory is associated with a physical hazard. Q90. Which of the following is considered a physical hazard in a lab? A. Burns from hot surfaces, B. Toxic chemical exposure, C. Infection from biological materials, D. Electrical shock. The correct option is A. Burns from hot surfaces are considered a physical hazard in a lab. Q91. Which instrument would you use to measure the diameter of a wire with the highest accuracy? A. Meter ruler, B. Vernier calipers, C. Micrometer screw gauge, D. Measuring tape. The correct option is C. The micrometer screw gauge is used to measure the diameter of a wire with the highest accuracy. Q92. How many significant figures are in the number 0.03040? A. 2, B. 3, C. 4, D. 5. The correct option is C. The number 0.03040 has 4 significant figures. Q93. What does accuracy refer to in measurement? A. Closeness to the true value. B. Consistency of repeated measurements. C. The smallest measurement that can be taken. D. The largest measurement that can be taken. The correct option is A. Accuracy refers to the closeness of a measurement to the true value. Q94. Which of the following measurements is most precise? A. 5.00 cm, B. 5.0 cm, C. 5.000 cm, D. 5 cm. The correct option is C. The measurement 5.000 cm is the most precise. Q95. Which type of hazard is associated with handling acids and bases? A. Chemical hazard, B. Physical hazard, C. Biological hazard, D. Safety hazard. The correct option is A. Handling acids and bases is associated with a chemical hazard. Q96. When multiplying 4.56 by 3.2, how many significant figures should the final answer have? A. 1, B. 2, C. 3, D. 4. The correct option is B. When multiplying 4.56 by 3.2, the final answer should have 2 significant figures. Q97. If a digital stopwatch shows 12.34 seconds, what is its least count? A. 0.1 seconds, B. 0.01 seconds, C. 0.001 seconds, D. 1 second. The correct option is B. If a digital stopwatch shows 12.34 seconds, its least count is 0.01 seconds.